When you think about the birth of humanoid robotics, where does your mind go? Some high-tech lab in Boston, maybe, or a futuristic research center over in Japan? Well, the story we usually hear is this nice, clean line of progress coming from a few famous places. But history, well, it's rarely that simple. The real story has a much, much more surprising origin point, one that kind of rewrites the very first chapter of Bionics. Because one of the most important blueprints for the robots we see today wasn't drawn up in Silicon Valley. Nope, it was engineered way back in the early 1960s in Belgrade. This is the incredible story of a forgotten giant, the Belgrade Hand. So for this whole deep dive, our guide is an absolutely fantastic article over on en.techfocus.rs, which just lays out this incredible history in amazing detail. I seriously recommend you check it out for the full story. Okay, let's get into it. To really get why this was such a massive breakthrough, you have to picture the early 1960s. We're talking about an era long before microchips, before lightweight composite materials, before any of the modern sensors we take for granted today. Back then, advanced prosthetics were basically just mechanical hooks or maybe these heavy-duty industrial-style grippers. I mean, they were functional for sure, but they were just tools. They could clamp down on something, but they couldn't, behave like a hand. They had zero of the nuance of human anatomy. But over at the Mihailo Pupin Institute in Belgrade, two visionaries, Professors Rajko Tomović and Miodrag Rakić, they had a totally different philosophy. They figured that to build a truly better machine, you didn't just need better gears and motors. No, you had to actually replicate the biological system itself. And that was a completely radical shift in thinking. And that biological approach, well, it led them straight to a technology that would end up defining the entire future of bionics. It was the first time anyone had bridged that gap between human intention and machine action in a five-fingered device. That technology was myoelectric control. And the concept is it's as elegant as it is powerful. It's all about using the body's own natural electrical signals from your muscles to command a machine. So instead of relying on awkward straps or clunky external switches, the machine would listen directly to the user's body. So here's how it worked. It all starts with human intention. The user would just think about closing their hand and contract their forearm muscles. Tiny sensors right on the skin would pick up those minute voltage changes, amplify that incredibly weak signal, and then boom, the motor activates. The hand moved simply because the user's muscles told it to. Mind-blowing stuff for the time. But, having a control signal is only half the battle. The team then had to build a hand that could actually translate that signal into complex human-like motion, using only the tech they had in 1963. And what they came up with was it was pure engineering art. Think about it. Modern robotic hands can have dozens of motors, but in the 60s, that was just impossible. Too heavy, too bulky. The Belgrade Hand solution was just incredible. A single, tiny DC motor drove all five fingers. How? Through this unbelievably intricate system of levers and linkages that distributed the force. One expert even called it engineering art akin to a watch mechanism. In a world before microcontrollers, this kind of mechanical elegance wasn't a choice. It was an absolute necessity. And it gets even crazier. The hand had sensory feedback built right in, creating what they called an artificial reflex. So if the hand was closing and it touched something delicate like a raw egg or a tomato, sensors would detect the contact and automatically cut the power to the motor, preventing it from crushing the object. This adaptive grasping, the ability to literally feel an object and react, was all achieved without a single computer. The intelligence was baked right into the hardware. This comparison really puts it all into perspective. On one side, you have the standard two-fingered rigid grippers of the 1960s, and then you have the Belgrade Hand, with 5 anatomical fingers, myoelectric control, and adaptive sensory feedback. Honestly, the core architecture is strikingly similar to modern bionics. The biggest difference between 1963 and today really just comes down to better materials and much, much faster processing. Which, of course, brings us to the central paradox of this whole story. If the Belgrade Hand was so revolutionary, literally decades ahead of its time, why isn't it a household name? Why did it become a forgotten giant? Well, the answer isn't that it was some kind of failure. Actually, it's the opposite. Its success as a research platform was global, and it attracted attention from the absolute highest levels of science and technology. This thing drew serious international interest, including from the US National Academy of Sciences. Get this, NASA researchers even studied it for potential uses in space, like orbital servicing, using robots to repair satellites. This little idea traveled from a lab in Belgrade all the way to the heart of the American space program. So, here's the catch. While the concept was an absolute triumph, the technology of the era just couldn't keep up. The prototype was built out of metal, which made it way too heavy for a person to wear every day. And 1960s battery technology, it just wasn't good enough to support a powerful, portable, autonomous device. It was truly an idea that had arrived way before its time. So its real legacy wasn't about being a commercial product you could buy in a store. It became something arguably way more important, a foundational research platform. It was a real, tangible blueprint that proved these concepts of bionic control could work, and it taught an entire generation of engineers how to even start thinking about building human-like robotic systems. And that idea, that blueprint, has had this profound, lasting legacy that continues to echo in the world of robotics even today. And that legacy is still being uncovered. What you see here is an original Belgrade Hand, preserved as a museum artifact, right next to a modern dynamic radiograph, basically an X-ray in motion, taken 60 years later. This new tech actually confirmed the incredible precision of those original watch-like mechanics, validating the genius of the design decades after it was first built. And the international robotics community, they never forgot. As recently as the 2000s, scientists would visit the Mihailo Pupin Institute, see the old artifacts, and ask their Serbian colleagues, "What happened to you? You were number one." That quote just powerfully underscores the immense respect this project commanded across the world. The legacy of the Belgrade Hand is like a tree with all these branches. It pioneered the first 5-finger myoelectric hand, the first use of an artificial reflex for grabbing things, and that ingenious single motor design. But its influence went even further. The whole research environment it created led to the development of something called the zero-moment point theory, which is the fundamental math that allows bipedal robots like Honda's Osmo to walk and not fall over. The Belgrade Hand is just such a powerful reminder that real innovation doesn't always come from famous labs with huge budgets. Sometimes it just comes from pure vision. It proves that a massive breakthrough can happen far away from the spotlight and end up shaping a field for generations to come. To explore every last detail of this incredible story, I really encourage you to read the original article at en.techfocus.rs. Trust me, you will not regret it.